Let's look at exercise 2, the guessing game. So the idea with this program is to have the computer generate a number between 1 and 100, and then we are going to check to ask the user to guess that number and determine whether or not they have, first of all, guessed a valid number, and secondly, if they have guessed the correct number. Since we're going to be using dialog boxes with this program, you can see that I have imported javax.swing. I've just imported the whole library, and as you can notice, beside it I've put in a little comment that I need it for JOption pane. If we execute this program, we're going to watch it go line by line. The first thing that we're going to do is get the computer to generate a random number between 0 or 1 and 100. And how are we going to do that? Well, the first thing that we're going to do is we're going to use the math.random function, which is going to give us a number between 0 and 0.99999 repeating. We're going to then take that number and multiply it by 100 to give us a number between 0 and 99.9 repeating. We're going to then add 1 to that, so we get something between 0 and 100. And we're going to take that whole thing, and it's essentially going to be between 0 and 100.9 repeating, and we're going to change that from a double by the use of typecasting to an integer. So it's going to convert it over to an int, which is essentially just going to hack off the decimal, everything that comes after the decimal point. And we're going to store that in a variable called computer number. And our current computer number value is 19. Because I'm in debug mode, I get the ability to see the value of my variables. And we can see right here down below that that is currently 92. We're also, just so if you're executing normally, you can see what that value is going to be so that you can properly test your program. We've included a system.out.println statement that will print the current value out at the command prompt. Let me get over here to the guessing game. And the correct guess, it says the correct guess would be 92. Now I'm going to prompt the user through a dialog box to guess a number between 1 and 100. And I'm going to go ahead and enter a guess. I'm going to enter, let's start out with an invalid guess. I'm going to enter -1. I'm going to then take that value, because remember, everything that comes out of an input dialog is a string, so we've stored it in a string. And instead I'm going to take that string and I'm going to convert it into an integer. So, because I can't compare numbers unless everything's a number. So I'm going to convert that into an integer and I'm going to store it in user answer. And if we jump back over to our variables, we can see that user answer currently stores an int, and the value is -1. We're then going to show a dialog box that says your guess is, and the value of determined guess. Now if we come down here and look at determined guess, we see that determined guess is returning a string. It takes in 2 integers. The first one represents the answer that the user gave us, and the second one represents the number that the computer generated when our program started. So we're going to come down into this method providing those 2 values. And the first thing we're going to do is check to make sure that user answer is greater than or equal to 0 and less than or equal to 100. That means that if it is less than 0, or I'm sorry, if user answer is less than or equal to 0 or greater than or equal to 100, if it falls into those ranges, so if it's 100 to anything up to infinity, and if it is negative, any negative number down all the way down to -infinity, it's going to trigger, if either one of those is true, then we're going to print the statement that your guess is invalid. And my guess is invalid because we told the user to guess between 1 and 100. So let's run this again, and this time let's give it a correct guess. I'm going to skip through this first part. I'm going to go ahead and enter a guess of, let's enter a guess of 80. Since the correct number is 85, let's enter a guess of 80. We're going to parse that into an integer, and now we're going to call determine guess. So is 80 less than or equal to 0? That statement is false. 80 less than or equal to 0 is false. 80 is not less than, it is greater than. Is 80 greater than or equal to 100? And that answer is also no. 80 is not greater than or equal to 100. 80 is less than 100. So this test right here is going to fail. We've encountered this already when we were looking at the code from one of the Alice projects. This right here, the double pipe, that's going to be the symbol above the backslash key on the keyboard. So shift // is what we call logical OR. Logical OR says at least one side of this combined statement must be true in order for the entire statement to be true. And right now, both sides of that statement are false. So the entire statement is false. So we're going to go to the first if that we have, or the first else that we have. And that else happens to have an if that goes with it. And it asks the question, is user answer the same as computer number? Well, is 80 the same as 85? And if the answer to that question is no, if 80 equal to 85 is false, then we're going to fall to the next else, which is, in this case, is our catch-all. And it's going to return the answer incorrect. Now, let's run this again, and this time, let's give it a correct answer. Let's find out what our correct answer is and give it. And if I go back over here, in this case, it's going to be 94. So I'm going to enter 94, and I'm going to click OK. And we're going to convert that to an integer, and we're going to call determine guess. Now, this time we're asking the question, is 94 less than or equal to 0? That is false. Is 94 less or greater than or equal to 100? And that is false. Both sides of the OR are false. The whole statement is false. So we drop down to the else, the first else. Else if, we've got another test, is 94 equal to 94? The answer to that question is yes. So this is the true portion of that. We're going to go ahead and execute that, and it's going to come back with the answer is that your guess is correct. Notice how I tested this, and I ran through this by providing an invalid value, an incorrect value, and a correct value. When you have multiple opportunities for your if statement, if you've got multiple tests going on, then you have to test all of the tests. And really, we can't even be sure that this is going to fail properly until we test for both user answer being less than 0 and user answer being greater than 100. That's the only way we're truly going to know for sure. So every test that you have in here, you have to make it false at least once in order to be sure that everything's working appropriately. We have to make sure that it responds appropriately when user answer is greater than 100. We also have to make sure that it responds appropriately when user answer is the same as computer number. We have to make sure it responds appropriately when user answer is less than 0. And we need to make sure it responds appropriately when user answer is not the same as computer number. So we've got 4 different avenues here to test. Something you're going to want to keep in mind when you're using decisions is you start getting more and more possible outcomes, the more ands and ors you tack on, the more else if statements you tack on, you start getting more and more possibilities. So you need to make sure you check all of those possibilities to ensure it works. And that's where flowcharts are going to come in handy to help you figure out the flow of your program, all of your decisions, and every decision that you need to test. If you have any questions about this exercise, you can send me an email or talk to me during class. We will give an opportunity to review this the next time that we meet. Again, thank you for watching, and you can move on to Project 3.